In this lesson, we're going to look at the graph of the parent secant function. So we want to make sure that we could graph this, and what we're going to see is that it is based on what we do with the cosine function. Here you can see the parent cosine function. That's the pink graph right here, and you can see all of the interesting little points that we graphed when we were graphing the parent cosine function. And the blue function is the secant function. So when we graph secant, and we'll see this for cosecant as well, for secant, we're going to want to graph a cosine function so that we can find the maximums, the minimums, and the zeros, and that is going to allow us to graph the secant function. So the domain of secant of x is all real numbers except odd multiples of x over 2. You can see at all of those odd multiples of x over, not x over 2, pi over 2. I don't know why I continue to say x over 2. Of the odd multiples of pi over 2, secant is going to have a vertical asymptote. So we want to identify where those are and pull those out of the domain. As far as the range is concerned, it goes from negative infinity, this function, all these pieces keep going down to negative infinity, and they come up and stop at the minimum for cosine. So that's this piece of the range, negative infinity to negative 1. And you can see here on this piece of secant, they go up to positive infinity, and they start here at positive 1. So that's this piece of the range. Secant, like cosine, is an even function. It is symmetric about the y-axis. So we want to make sure we know secant is an even function. It is periodic, and its period comes from cosine of x. So it repeats its behavior every 2 pi. You can look on the interval from 0 to 2 pi, and we have this piece of the secant function, this piece of the secant function, and this piece of the secant function. So it goes through a complete rotation around the unit circle, and these are the pieces that show up when we graph it like we did. There are no x-intercepts. There is only one y-intercept. That's this point that's at a maximum for cosine. There are no minimum values and no maximum values. So there is the parent graph of secant of x. So if we wanted to graph 2 secant of 2x, we're going to first graph the cofunction 2 cosine of 2x. We see that cosine has an amplitude of 2, and we see that it has a period of pi. So we're going to first graph that function. So here we are. Here is the maximum. It has a 0 at pi over 2. Comes down here and has a minimum. Sorry, that's pi over 4, has a minimum at pi over 2, has a 0 at 3 pi over 4, and has a maximum again at pi. So this is the graph of the function 2 cosine of 2x. The key points that we want to look at on this graph are the point 0, 2, pi over 4, 0, pi over 2, negative 2, 3 pi over 4, 0, and pi 2. So now at every 0 that this function has, we're going to draw a vertical asymptote. There's a vertical asymptote at pi over 4. There's a vertical asymptote at 3 pi over 4. And that is going to allow us to graph the secant function so that it follows those vertical asymptotes. And we can see that this function continues to go in that direction, but it follows the asymptotes. It continues to go in this direction, following the asymptotes. So we graph first that cofunction. This red function was that y equals 2 cosine of 2x, and we can go from the maximum and go up, and we can go from the minimums and go down. And we're guaranteed doing it that way, we will always get an accurate graph of the secant function. So the blue function here is y equals 2 secant of 2x. So that's it. Short little lesson. We don't spend a whole lot of time graphing secant, but it is something that we need to see and we need to know about. Come to class next time and we'll practice graphing secant functions.